Hey, geometry, coming right back at you. So we already talked about some circle stuff, some arcs and some chords and stuff like that. So now we'll do a little bit of calculations. I hope you found finding all the arc measures not so difficult. We'll clear up any questions you have when we have a meet. And don't forget, you can always, Monday, Wednesdays, and Fridays, unless you're told different, 9 to 10 I have my virtual office hours. So you can always jump into my virtual office hours Monday, Wednesday, Friday at 9 o'clock in the morning, or you can always just shoot me an email, as some of you have been doing. So don't be afraid if something's bugging you. Don't just sit there and get mad about it and pout and go play Xbox. You know, reach out to me on your email. You have your Chromebooks. So what we're going to look at today is a couple simple calculations. One of which is not new to you at all because you've done it before, and that's circumference. Okay, circumference. Okay, you know, circumference. He was the only knight at the round table that measured up. Circumference. Another bad joke for you. Anyway, what is circumference? The circumference of a circle is the perimeter. The perimeter of a circle. Okay? It is the perimeter of a circle. And why don't we call it perimeter? We don't call it perimeter because typically for perimeter is for a polygon. And circles are not polygons, they're round. So we give them everything with circles has its own special names, and circumference is no different. So, do you remember how to find circumference? We did this in chapter 1. It was back in September. So, circumference, two formulas. I prefer this one. Pi times the diameter. I like that one. You may have learned it different in grade school depending on what teacher you had. I prefer this formula. I think it's less confusing because when we throw in the area formula, if we make that 2 pi r, people get confused. So I like pi times d. So just a quick note about pi. What the heck is pi? Well, all of you know it was pounded in your heads. Pi is 3.14. 3.14159265. If you have a pi key on your calculator, use it. It's there for a reason. It's more accurate. But where does pi come from? Every single ancient civilization that developed the wheel, so that leaves out most of North and South America, because North and South American tribes did not have the wheel. All the ancient civilizations that had the wheel, for the most part, had a value for pi. Why? Because they were building wheels. What were they building wheels out of? Well, they were building wheels out of wood. So how did they figure it out? Well, they figured out pi, what we call in mathematics for science, we figured it out empirically. Empirically means they just kept doing it over and over again, and this is what it came out to be. How did they figure it out? Well, look at this formula. C equals pi times d. A little bit of simple algebra. Pi is the circumference divided by the diameter. If you divide both sides by d, boom, you get that. That's the definition of pi. This is the definition of pi. If I went out and asked people, what's the definition of pi? Most people are going to tell me 3.14. No, that's the value of pi. Ask people where pi comes from, they don't have a clue. Pi comes from, you take a circle and you measure once around. That measurement once around is called the circumference. And then you divide it by once across. The circumference divided by once around divided by once across, guess what it works out to? Every single time in any circle. 3.14. 1592654. And that goes on forever. It's an irrational number. I'm not going to get into all that. It's 3.14. The ancient Greeks had it down. The ancient Greeks, check this on your calculator. This is what the ancient Greeks had. 22 sevenths. Guess what 22 sevenths is? 3.14. After the third decimal place, it deviates a little bit, but they had it figured out pretty darn close. Okay? So anyway, circumference is pi times diameter. Now you know where pi comes from. Okay? And we've only been using the Greek letter pi for about 150, 200 years to represent that value. Before then, people just wrote 3.14. Okay? But isn't it cooler to write pi? I think so. Okay? So, how do we figure out circumference? Well, to give you circumference, I need to give you a number here. So let's suppose this is 4 inches. What is that 4 inches? That's the radius of that circle. So if I want to figure out the circumference of this circle, circumference is pi times diameter. Okay? So in any circle problem, some of you won't have to do this, some of you this will benefit. Write this down. R is 4, so what's D? D is automatically 8. Okay? If we were still in school and we were doing this quiz after all these lessons, every problem with a circle, I would have this little box. Why? Not so I can check that you have the right R and D, but so that you have the right R and D. Because it's so easy to look at this and get mixed up. So what do we need here? The diameter. So circumference is pi times 8. Well, pi times 8 sounds dumb. We don't like that. How do we normally say it? 8 pi. Putting the number first. You know, we don't ever say, we always say 8x. We don't say x8 because x8 doesn't sound good. It's 8x. So 8 pi. This is in terms of pi. What's the difference here? Sometimes you'll be asked to leave in terms of pi. If you're asked to leave the problem in terms of pi, boom, you're done. 8 pi. What if it says round off? We're going to round to 2 places. Well, now we get the approximate symbol, the double squiggle. Okay, 8 pi. So what do? You go to your calculator and you hit 8 times pi, and it's going to give you 25.1327, which I'm going to round off to 2 places, 25.13, and this would be in inches. The 8 pi is also in inches. Why is it in inches? Because we have inches here. Okay, so that's easy. We did that in chapter 1. Trust me, we did it. I remember grading it. We did it in chapter 1 back in September. Okay, so that's easy. You did that before. There's nothing new. That's review. That's review. Now we get into this. Now we get into the second half of this short little lesson. Up here, arc length. Arc length. What is arc length? Arc length is the length of the arc. Got it? Yeah, I know. That's kind of funny. Anyway, arc length is, if we're going to find the length, let's say the length of arc AB. So we want to find the length of arc AB. Right here. Boom. How long is it along there? Remember in my last video I said arcs are crust of the pizza. How long is the crust of the pizza? If you walk around your friend's round swimming pool and you walk from one spot to another, how far did you walk? That's arc length. It's the length of that arc. Arc length is parts of the circumference. So guess what? Part of the circumference. So guess what? We got, what was our answer? Like 25.13 when we did the circumference. If we get a number here that's bigger than 20, it can't be bigger than 25. It's got to be smaller. Look at this. How are we going to find the length of that? Find the length of arc AB. Arc AB is right here. It's a minor arc, only 2 letters. It's a minor arc. Well, here's what we got to do. I gave you this 60 degrees for a reason. It's not there just to look pretty. It's there because we need it. 60 degrees. Out of. How many degrees are in a full circle? 360. Very good. Times the circumference. 60 out of 360 times pi times the diameter. The diameter was 8. Oh, I don't even like writing pi times 8. That's why I'm going to erase that and put 8 pi. Okay? Part of the circumference. What part is it? 60 out of 360. Yes. Unfortunately, there's fractions. Well, let's see. I can cross these zeros out, right? 6 out of 36. 6 into 36. Oh, that's 1/6 times 8 pi. Okay. Now, if we finish that, that's 8 pi over 6, which is going to be what? 4 pi over 3. Right? Because 2 will go into 8, 4, 2 will go into 6, 3. It's 4 pi over 3. What the heck is 4 pi over 3? Well, again, probably more for my accelerated students. Every now and again, we might want to keep it like that because if we plug it in somewhere else, somewhere later, it might be able to cross out. But probably more often than not, we're going to get that into a decimal. So over here, let's get this into a decimal. Maybe you don't even, maybe you just go right here. You know, 60 divided by 360 times 8 pi. You can get that to a decimal. So let's see what that looks like as a decimal, depending on how your calculator works, because I don't know what kind of calculator you have. So I'm going to do 60 divided by 360. I know that's 1/6. So then I'm going to go times 8 pi again, and I got about 4.19 looks like. This is about 4.19, and that would be inches. This is a length. Even though it's curved, it is still a linear measurement. It's a length. So since this was 4 inches radius, this arc length is 4.19 inches. Let's see, does that make sense? Well, our circumference earlier was about 25. What's 1/6 of 25? Well, let's see. 1/6 of 24, 4 times 6 is 12. Guess what? We should be right around 4. Boom, there we are. So it seems pretty plausible that we are correct. Okay? So let's do one more here. Let's just go through one more time. One more time really quick. And let's find the length of arc DB. So in this problem, arc DB. Well, remember we did the arc measure stuff, messing around with those angles in the last video? Boom. DB. How long is that? Some of you, if you're clever, will recognize, well, let's see, this is 120 degrees, Mr. Litzkanen. So shouldn't it be twice as big as that? And if you're thinking that, I like your thinking. So hopefully you're thinking that through. It should be about twice as big. Well, let's see. Let's see. So it's part of the circumference, so it's going to be 120 out of 360 times 8 pi. Remember 8 pi? Where we get the 8 pi from? Pi times diameter. This is pi times diameter. This is the diameter times pi. Pi times diameter. Boom, right there. 120 out of 360. If I cross the zeros out, that's 1/3 times 8 pi. I like to, you know, I'm from that generation where we didn't have these little machines, so we learned fractions. if you go to your calculator, let's see, that's 8 pi over 3. Let's see here. 8 pi, boom, divided by 3, 8.377. That's 8.38. This is about 8.38 inches. Remember earlier I asked you if you were thinking? And is that twice as big as what we got for this one? You bet it is, because I thought we had about 4.17 maybe? So 8.38 is really, really close to being twice that value. So that sounds pretty good. 8.38 looks good. And again, if we take 8.38 plus that 4, we get a little bit more than 12. And a little bit more than 12 is half of the total circumference of 8 pi, which was 25.17 or something it was. So we're right there. Everything seems okay. So this is how you find arc length, circumference and arc length. The arc length, all you got to do is put this little fraction in front of the circumference. Circumference you've already done. Okay? Folks, stay safe. My next video will be all about area of a circle. Until then, catch you later.